All right, we're going to talk about finding area and perimeter on the coordinate plane. So we will need the distance formula, so we're going to go ahead and fill that in. You would subtract your x's and square it, and add that to the difference of your y's squared. Okay. So subtracting your coordinates, but adding their squares. All right, and then square root at the end. If you have a distance that is either perfectly horizontal or perfectly vertical, you can just count those based on the boxes. So here this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across. Or here this is 1, 2, 3, and 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. Or here you have 1, 2, 3, 4. And 1, 2, 3, 4, 5. And then you only have to use the distance formula on the ones that are diagonal. So we're trying to find area and perimeter. If I go ahead and do area, I can make my height here for my triangle, and that's 1, 2, 3. So 1/2 base times height would be 15 square units. Okay, perimeter, I'll need to find the distance here. So this point is -1, -2, and this point is 2, 1. So if I were to use my distance formula, I would have to take 2 minus -1 squared and negative, or not, since I started with this one, I still have to keep starting with that one. So it'd be 1 minus -2 squared. Okay, so I'm not going to write all of them out, but this one would be 3 squared plus 3 squared. So then the square root of 18. Okay, and we're going to go ahead and round today. So this would be 4.2. And if I do the same thing with this point, this one is -8, 1. If I subtract my x's, I should have -7, so 7 squared. Here, 1 minus -2 is 3, so plus 3 squared is 58. The square root is 7.6. Okay, so if you add those together, 10 plus 7.6 plus 4.2 is 21.8 units. Okay, here we have a trapezoid. So our area formula is 1/2 base 1 plus base 2 times height. So then that would be 24 square units. Half of 8 is 4 times 6 is 24. And then I still need to find this side for my perimeter. So this is -7, -2. And this one is -5, 4. So I'd use my distance formula. So if I subtract my x's, -5 minus -7 is only 2. So I'd have 2 squared. And then 4 minus -2 is 6, so plus 6 squared. So the square root of 40 is 6.3. So then if you add these all together, you'd have 20.3 units. Okay? And if it asks for exact form, you could do that. You just need to leave this as a simplified radical, which would be 2 root 10. They might ask you for that. And then you'd add them all together. And this one would be 14 plus 2 root 10, and depending on your instructions. But we're going to go ahead and round those today. Here you have 5 and 4. Area for a triangle is 1/2 base times height. So half of 20 is 10 square units. And then to find my perimeter, since this is a right triangle, you can use your distance formula or Pythagorean theorem. I'm going to go ahead and use Pythagorean theorem. So this would be 16 plus 25 is 41. which is 6.4. So when you add them all together, you should get 15.4 units. Okay? Or they wanted exact form. This was just root 41. That doesn't simplify. And it would be 9 plus root 41 units. Okay, so that's exact form. This is approximate. Determine the area of the following polygons. The suggested technique is the box method. And the main reason we suggest that is because then you don't have to use the distance formula. You have enough vertical and horizontal lines. So if you do this whole box, the total area would be 1, 2, 3, 4, 5, 6. And along the bottom, 1, 2, 3, 4, 5, 6 again. So my total area is 36 square units. Okay? And then for this triangle, I have 1, 2, 3, 4, 5, 6 still. And 1, 2, 3, 4. Half of 6 times 4 is 12. Up here, this side is 2, this side is 6. Half of 6 times 2 is 6 square units. And here I have 2. Here I have 4. Half of 2 times 4 is 4 square units. So if you take 36 and subtract 4, 12, and 6, you end up with 14. So 14 square units is this green triangle in the middle now. Okay? And so we'll do the same with this hexagon, or actually pentagon, 5 sides pentagon. I'm going to make a box on the outside. Okay, so my total area, 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7. So my total area is going to be 56 square units, because you just multiply those together. And then we're going to work on the triangles on the outside. So this is 1, 2, 3, 4. 1, 2, 3, 4, 5. So half of 4 times 5 is 10. Here you have 3. Here you have 2. So half of 3 times 2 is 3. Then you have 1 by 4. Half of 1 times 4 is 2. And then 2 by 3. Half of 2 times 3 is 3. So we would take our 56 minus 2, 3, 10, and 3. And get 38 square units. All right, today we're going to work on these grazing problems, which allow us to take what we've been learning about composite areas and kind of put them all into one problem. So we're going to draw this diagram together first. On your assignment, they're drawn for you, except for the area they graze, but they're started for you. So we're going to go ahead and start with a 4 by 5 meter shed. And these are not going to be to scale, but we'll try to get close. So we'll say that this is 4 meters, this is 5 meters, and then there's an 8 meter piece of rope. So we'll say that's about right. Again, not to scale. And then essentially, if there's a goat on the end of this rope, they can eat in a full circle. This is like a radius. Okay, they can graze this whole area. Now, again, this is not to scale, so I'm going to get rid of this circle. But they could go all the way up to here if this is 4 more meters. Okay, so we'll say that that is where they can go, and then really they could keep coming around here because their rope is longer than this. So they could keep going here where the radius is 4. And then same thing, if I extend this 3 more meters, so that this is 8 total, they could graze to there. And then they could graze here where this is 3 meters. Okay, they could go around the corner, essentially. So again, it's not a perfect circle in my drawing, but it would be in real life. So if this was a perfect circle, they can't graze here because this is the shed, but it's a 90-degree angle. So I'm finding 3/4. So really I have a circle here. And I'm finding this 3/4 of it, okay, with a radius of 8. Okay, so that would be 3/4 of pi r squared. Okay, we're going to go ahead and use exact form today. So 8 squared is 64. 64 times 3/4 is 48. So this would be 48 pi for this big area here. Okay, I still have to find these two smaller areas, which are 1/4 of a circle each. So say we do this one first. I'd have 1/4 of pi r squared, and that radius is 4. So that's 16 divided by 4 is 4 pi. Okay, so that's this area. And then here I'd have 1/4 of pi 3 squared. So 9/4 pi. And then you would just add them together. So 48 plus 4 plus 9/4 is 54.25 pi. And its area, so it'd be square meters.